So scoping a result also means to only focus on specific parts of the geometry and not all the bodies. So we can scope, for example, a single part, a surface, an edge or path, or even a node or an element. So now you see we have the safety factor stress tool solved for all the bodies at the second step of the analysis. But now let's say we want to apply the stress tool to only the lifting lug. So let's add another safety factor tool by clicking on the stress tool, right-clicking, insert, stress tool, and safety factor. Now this time, instead of using all bodies as the geometry, let's go ahead and click on the body filter, and then let's just click on the lifting lug, and then clicking on all bodies here, click apply. Now you can see that the geometry is selecting only one body. So now let's right click on safety factor number 2 and click on evaluate the results. So the safety factor now at time step 2 is 2.57. And if we want to see it at time equals 1, we can duplicate this again by right-clicking on it, clicking on duplicate, and we can choose by time and choose 1 here, and then right-click on safety factor 3 and click on retrieve this result. So you can see after the pre-tension we have a safety factor of 3.5, and after the tension and then loading we have it dropped down to 2.57. Now if we want to see the stress on just the lifting lug, we can click on equivalent stress here, right-click, and then click on duplicate without results. And then here in the geometry we can select on all bodies, use the body filter, select the lug, and then click on apply, and then right-click on equivalent stress 2 and click on evaluate all results. Now we can see that the maximum is at the bottom of one of the bolt holes right here, and that maximum is at 97 megapascals. Now if you just wanted to scope a face, we can click on, let's say, equivalent stress 2, right click, duplicate without results, and this time click on the one body here and use the face filter and click on, let's say, this face over here and click on apply. Right-click on equivalent stress 3 and evaluate all the results. So now we've scoped just this face, and now you can see that the maximum stress along this face is 33 megapascals. Now in addition to the contoured results, we can also plot reaction forces, moments, and even the pretension results. And you can do that by right-clicking on the solution, insert, and going to the probe menu here. And now you can see force reaction, moment reaction, bolt pretension, etc. So let's click on force reaction. And now let's choose the fixed support. Weak springs are inserted automatically by ANSYS by default in order to converge the solution if it's not fully defined. So let's ignore that for now and let's click on fixed support. And let's also add in solution a bolt pretension. And let's choose, let's say, one of them, we'll choose the first one. Now let's click on the solve button up here. Now if we click on the force reaction, we can see here in the table that we have the force reaction in the X, Y, and Z directions for the fixed support. So if we look at the total reaction force for step 1, which is almost 0, which is just the preloading case, and then step 2, which is about 7,000 newtons. And for the bolt pretension probe, we can see that the bolt pretension preload reaction in newtons is about 2,700. Now you can also export any result by, let's say, right-clicking on one of them and clicking on export. And you can export it to a text file or an STL file. Another way of exporting the data is actually going into the tabular data window down here, and you can actually select these columns, right-click, and click on export as well. This method will allow you to export to an Excel file. Now if you want to export the node locations with this information, you can go into the Tools menu, Options, and under Mechanical and then Export, you can choose to include node location. So right now it's set to no, you can put that as yes, and then hit OK. Now you can also insert an error result based on the stresses of the analysis to help identify regions of high error, which is usually associated with low mesh quality. In order to do this, you can right-click on Solution, insert, stresses, and then click on error, and then click on solve to solve for the structural error. Now these energy values are only relative, so the actual value doesn't have much meaning here. So here we can see that in this region, the mesh quality could be refined in order to reduce the error of the results in this area. Which brings me to my next topic, which is about convergence.